All right, guys, so we're gonna do 7.2. Hopefully I tried a few different things. Hopefully it's a little bit louder now. Hopefully it is not so glitchy this time. Um, to be perfectly honest, I won't know until the video is done though, so we're gonna work with it. We're gonna hope for the best. If it's not better, I apologize. I'll have to figure it out after this. But we're gonna start with 7.2, the cosine law. That way you guys have all of your chapter 7 notes for the weekend. Okay, so it says that in section 7.1 you use the sine law to solve for unknown side lengths or angles of oblique triangles, but only if you knew two side lengths and an angle opposite one of them, or two angles and a side length opposite one of them. So these are the conditions for using your sine law. This isn't always going to be the case though. There's other situations where we can't use the sine law. We have to use something known as the cosine law. So with the cosine law, you can solve for the third side length of a triangle if you know two side lengths and the angle between them, or any angle if you know the lengths of the three sides. Okay, so these are the other two situations that we can solve for now using the cosine law. So the cosine law states that in a triangle ABC, a squared equals b squared plus c squared minus 2bc cos A, and it can also be written as cos of A equals b squared plus c squared minus a squared over 2bc. So you're given these two formulas on your formula sheet. This version, the top one, is for solving for a side. This version is for solving for an angle. Okay, and just like in the sine law, we had to look for angle side pairs that are across from each other. The cosine law also works the same way. Whatever the side you're solving for is, this angle over here, the A and the A have to be opposite to each other. So if you're solving for side A, you have to know the angle across from it. So they're opposite to each other. Same if we're solving for an angle. If we're looking for cos A, this side right here, the one that we're subtracting in our formula, has to be the side across from the angle we're solving for. Okay, we're always looking to pair those up. Okay, so again, if we have our triangle, the capital letters are the angles, the lowercase letters are the sides. Okay, so the first example says calculate the length of side A. In this case, we only know one angle, and we know two sides. So as long as we have what's called side, angle, side, where we've got a side, an angle, and a side, all three in a row, we can solve for that third side. The other way of thinking of it is if we have two sides, and we know the angle that's directly across from our unknown side, we can solve for that unknown side. Okay, so that's what they do in this example. We're using our cosine law solving for a side. So side A is the first piece that's written. So we're using the side version. It doesn't matter which side we call B and which side we call C. What's the most important thing is that this angle right here has to be the angle across from the side that we're solving for. So they're just filled in their two side lengths. Simplified the beginning part first, so we squared them, we added them together. Your calculator will do this all in one step as long as you're careful when you put it in. And then when you get to your very last step, you have to take the square root of both sides in order to cancel out the squared on the A. We're not looking for a squared, we're looking for a. So you need to make sure you cancel that out. It's going to give you an approximate answer, but approximately 5.4 in this case. Okay, so same deal here. We're looking for a side length. We have two sides. We have one angle. That's a pretty good indication that we can use our cosine law. I can't use my sine law because I don't have another angles, or I don't have a pair where I know both the angle and the side. So right now, I can solve for this side so long as I know the angle directly across from it, which I do. I've got my two sides, I got my angle across from it, I can use the cosine law. We're solving for a side, we're going to start by writing our side first in our formula. So our formula is a squared equals b squared plus c squared minus 2bc cos of angle A. So it doesn't matter what I call b, what I call c, but I'm solving for a squared equals, or in this case they called it r, so we'll call it r as well. So r squared equals 4.3 squared plus 6.5 squared minus 2 times 4.3 times 6.5, so my other two sides, and then times cos of 61. If you work this all out in pieces, you're going to end up with r squared equals 18.49 plus 42.25 minus 55.9 cos 61, which means r squared equals 33.64. And then your last step is take the square root of both sides so that the squared cancels. So you just get r equals the square root of 33.64, or r equals 5.8. And because we had units in our question, we need units in our answers. It was kilometers originally, so 5.8 kilometers. Okay, don't just copy these down. Make sure you're putting them in your calculator, make sure you're getting the right answer. If you're not, double check that you are in degree mode on your calculator, not radian mode. It's going to make a difference. Okay, next question, also looking for a side length. As long as we know this angle directly across from this side and we know the other two sides, we can use our cosine law. In this case, we're good. We've got everything we need. So we're solving for a side. We're going to write our formula with the side length first. So a squared equals b squared plus c squared minus 2bc cos of angle A. So we're calling it y. Y squared equals, doesn't matter if I call b 13 or 12.3 or 12.1, it doesn't make any difference whatsoever. So 12.3 squared plus 12.1 squared minus 2 times 12.3 times 12.1 times the cos of the angle across from the side we're looking for, so cos of 41. Y squared, if we put it all in our calculator, we're going to get approximately 73.1. And then we're going to do the square root on both sides. The squared cancels. Y is the square root of 73.1, which means y equals 8.5. And it was centimeters originally, so 8.5 centimeters. Okay, don't forget to take the square root at the end. That's the final step. Next one is a word problem. It says, Brent is a surveyor. He's been hired by city planners who are developing a park within the city. They want to build a bridge over a pond so that a walking trail can be installed. Brent collects the following measurements. What's the length of the pond from A to B? So we have all the information we need. we are looking for this side over here. We know the angle directly across from it. We have our other two sides. That means we can use our cosine law. So we're going to say a squared equals b squared plus c squared minus 2bc cos of the side across from the angle we're looking for. I just called it x, so we're going to say x squared equals my other two sides. So 152 squared plus 152 squared minus 2 times 152 times 152 times cos of my angle, which is 80 degrees. When you work this all out, my x squared equals 38184.1. And then I take the square root of both sides, get my squared to cancel. So x equals the square root of 38184.1. And x is going to be 195.4. And because I had units in my question, I need units in my answer. I had meters in my question. This is meters in my answer. Okay, one more side length type question on the next page. So it says Sheena and Lynn live on opposite sides of a pond. To get to Lynn's house, Sheena has to follow a sidewalk to the end of the pond, point X. Then take a path through the park to Lynn's house as shown in the following diagram. How much farther does Sheena have to walk than if she could take a straight line path to Lynn's house? So what it's saying is Sheena has to walk across this way 752 meters. Then she has to walk up this way to the house another 481 meters. So right now her walking path is 752 meters plus 481 meters. So she's walking 1,233 meters. What the question wants to know is if she could just go straight across to Lynn's house, how much shorter is that? We can find this distance as long as we know the angle across from it. And when I look at my angle across from it, I can tell from my diagram it's 73 degrees. So I've got two of my three sides of my triangle. I know the 73 degrees. I can solve for this straight across the pond distance. Solving for a side. So I want to write my formula with the side lengths. So I'm going to say a squared equals b squared plus c squared minus 2bc cos of angle A. I called it x, so x squared equals 752 squared plus 481 squared minus 2 times 752 times 481 times cos of my angle, which is 73 degrees. If I type all of that into my calculator, simplify as I go, I'm going to get 585356.3. Last step is to take the square root of both sides. Cancel my squared on my x. So x equals the square root of 585356.3. And so x equals 765.1. Same units as in my question, so meters. We're not quite done. It wanted to know how much farther does she have to walk than if she could take the straight line path. So if it takes her 1,233 meters to walk around, and it's a 765.1 meters straight line. We do the 1233 minus the 765.1. so she's walking an extra 467.9 meters. So that's our final answer. Okay, so that's how we do side lengths. Again, if you're not clear on the in-between steps, if you're not clear on the simplifying, make sure you ask. Don't just write these down. Try it on your calculator. Make sure you're getting the right answer. Okay, the next one is for how do we find an angle? We can find an angle so long as we have all three side lengths. So if we have three side lengths, we can find all three of the angles in our triangle. We're going to use the other form of our cosine law. So the cos A equals the b squared plus c squared minus a squared over 2bc. This is actually the same formula as the other one. It's just been rearranged to get the cos A part or the angle part by itself. The important thing to remember is the order that you put the sides in actually matters for this one, or for A at least. A has to be the side across from the angle you're solving for. Okay, if you put the wrong side in there, you're still going to get an answer. It's not going to, there's going to be no indication that it's actually wrong. It's just going to be the wrong angle. So in this case, I'm looking for the size of angle Q. So that means I'm looking for this angle right here, which means my A side of my formula has to be the angle straight across from it, the 16.9. The B and the C don't matter. The 21.6 and the 31.2 I can put in either order. I could say 21.6 is B, or I could say 21.6 is C. It's not going to change anything. But 16.9, the side across from the Q, has to be side A in my formula. If I don't do that, if I put, say, 31.2 as my side A, what I'm actually going to solve for is this angle over here, angle P. So whichever side I put in as my A in the formula, I'm going to solve for the angle directly across from it. So if I want angle Q, I have to make side A, the side straight across from it, the 16.9. So if you look at the next page, that's what they've done. They sub in their letters first, but basically you're just putting your numbers in. You're solving, so simplifying the top by squaring everything and adding them together, simplifying the bottom by multiplying. When you get to right here, to get rid of the cos on the cos Q side, we have to do the inverse cos, just like we did for the inverse sine with the sine law. We have to do that to both sides. That makes our cos -1 and our cos cancel and leaves just the Q, or just the angle we're solving for, on the left. And then we have to take the inverse cos of our fraction as well. It's going to give us our angle. Okay, so this question says, calculate the size of the indicated angle. The indicated angle is the one with the question mark. That's this guy over here. What that means is the side that's important, the side straight across from it, this has to be side A in our formula. The other two don't matter, that has to be side A. So we're going to use the angle version of our formula because we're solving for an angle. Cos A equals b squared plus c squared minus a squared, all divided by 2 times b times c. So in this case, we're talking about angle Z. So cos of Z equals, B and C don't matter which one we call which. So I'm going to say 8.2 squared plus 12.3 squared minus, this is the one that's important. This one has to be the one straight across from our angle, so 5.1. all divided by 2 times our B side times the C side. Okay, if we simplify the top, simplify the bottom, we end up with cos Z equals 192.52 divided by 201.72. And then to get rid of the cos and get just the Z by itself, we do the inverse. Causes that to cancel out. So Z is going to equal the inverse cos of 192.52 divided by 201.72. And if we put this on our calculator, we end up with angle Z equals 17 degrees. Don't forget the degrees symbol. Angles are always measured in degrees. Okay, next question. Indicated angle is angle T. This one right here, which means the only side that's really important is that one over there. Straight across from the angle has to be side A in our formula. Okay, we're solving for an angle, so we're going to use our angle version. So cos of A equals B squared plus C squared minus A squared over 2 times B times C. So cos of T equals, doesn't matter the other two, 165 squared plus 88 squared minus 116 squared, that's the important one, divided by 2 times 165 times 88. When we simplify all of this, we end up with cos of T equals 21513 divided by 29040. And we're going to do our inverse cos to have this cancel out. Those are going to cancel. It's going to leave us with angle T equals the inverse cos of 21513 divided by 29040. So angle T is going to equal 42 degrees. Okay, next one is a more real-world problem, or a word problem almost. It says at what angle of elevation is the longer section of this shed roof installed? Angle of elevation is always from straight across up to the line. So from straight across up to the line, this is the angle that we're looking for, the angle of the longer section of the roof. The roof makes a triangle if we close off this bottom piece. And we know all 3 side lengths of our triangle. We got the 9.2 for the long side, the 4.9 for the short side, and this 12.6 down here is straight across the building, which means it's also 12.6 feet right there. That gives us all 3 of our sides of our triangle. We can solve for our angle. The important side is the side that's straight across from our angle. That's going to be side A in our formula. So we're solving for an angle. We write our formula with an angle out front. So cos A equals B squared plus C squared minus A squared, all divided by 2 times B times C. Cos, in this case, we're talking about angle B, so cos B equals 9.2 squared plus 12.6 squared minus the 4.9, the important one, all divided by 2 times 9.2 times 12.6. So cos B when we simplify the top and bottom, is going to be 219.39 divided by 231.84. And then the inverse cos to get the b by itself. So b equals inverse cos of 219.39 divided by 231.84. And our angle B is going to equal approximately 19 degrees. So the angle of elevation of the roof is approximately 19 degrees. Just as a reminder, I probably should have said so earlier, if you're doing this inverse cos, you're doing the second cos on your calculator. So second button, cos button gives you that cos minus 1. Just like second sine gave you the inverse sine or the sine negative 1. Okay, next part is word problem. Every time you do a word problem, you want to start by doing a drawing, and this one actually makes you do a drawing for part A. So Giles has 3 pieces of wood that he wants to use to build a frame for his flower garden. The pieces are 10.2 feet, 7.5 feet, and 8.4 feet long. Draw and label a diagram showing the triangular garden frame. So we need a triangle. One of the sides is 10.2 feet. One of the sides is 7.5 feet. One of the sides is 8.4 feet. And it doesn't matter how you drew it or which sides you labeled what. It's all the same. You have a triangle, 3 sides, 3 numbers. The second part says, what will be the measures of the angles at the corners of the garden? We need to find all the angles. Which means we have to do our formula a couple times. I'm going to add some letters to our triangle just so that we can talk about which angle is which. And I'm going to call them X, Y, and Z. Okay, we need to find, if we can solve for 2 of our angles, we can do the third one the easy way by doing the 180 minus the 2 angles that we know. But we have to find 2 of them first. Doesn't matter where we start, we pick one of our angles and use our cosine law because we have all 3 of our sides. So I'm going to start with X, which makes my 7.5 my important side. That's going to be A in my formula. So I'm solving for an angle. I need my angle first. So cos A equals B squared plus C squared minus A squared, all divided by 2 times B times C. I'm solving for angle X, so cos X equals, so the only one that's important is my 7.5. It has to be at the end. So my 8.4 squared plus my 10.2 squared minus my 7.5 squared, all divided by 2 times 8.4 times 10.2. So cos X is going to equal 118.35 divided by 171.36. I'm going to do my inverse cos to solve for X. So we're going to cancel. X equals cos negative 1 of 118.35 divided by 171.36, which means it's going to equal in the end 46 degrees. That's one of my 3 angles. Okay, so we've got one of our 3 angles. We have to solve for at least one more of these angles using a formula. So we have options at this point. Since it's the cosine law section, we can use the cosine law to find another angle. And now that we know one of our angles, we could also go back to the sine law if we wanted to and use the sine law to find one more angle, because now we have an angle side pair that we know both pieces of. Depending on what you like better, either way is going to give you the same answer. Since we're working with the cosine law, though, I'm going to use the cosine law again. And I'm going to find another one of the angles. And I think the angle will be angle Y. So let's find this one, which makes the 10.2 feet the important side. That's going to be side A in our formula now. Okay, so same thing. We've got cos A equals B squared plus C squared minus A squared, all divided by 2 times B times C. And since we're finding side Y, or angle Y, we're going to call it cos Y equals, the other two are the not important ones, so the 8.4 squared plus the 7.5 squared minus the 10.2 squared, because that's the one across from the angle I'm trying to solve for, all divided by 2 times 8.4 times 7.5. So cos Y is going to equal 118.35 divided by 171.36. I'm going to take the inverse cos on both sides in order to get Y equals inverse cos of 118.35 divided by 171.36. When I put that in my calculator and I divide, I end up with angle Y equals 80 degrees. Okay, I'm just going to fill those in my diagram. So I've got my 80 degrees and my 46 degrees. So this right here is 46 degrees. This is 80 degrees. What that means is, to find Z, I now know 2 of the 3 angles in my triangle, which means I can do my 180 minus the 2 sides that or 2 angles that I know, and that'll tell me angle Z. So angle Z is going to be 54 degrees. If I wanted to, or if I didn't remember how to do this 180 minus, I could do my cosine law a third time and use the 8.4 as the A side in my formula and solve again for angle Z. But it's a little bit faster, a little bit easier to just do the 180 minus the 80 minus the 46, because a triangle always adds up to 180 degrees. Okay, this is a rate type question where there's a little bit more to it to figure it out. There was one of these on your test. You guys told me that you had not done no examples like this in the homework, but you just hadn't actually done the homework. Okay, you need to know how to do this type of question. It's exactly the same. There's just an extra piece you have to do to try and find your numbers for your triangles. So it says Mariah and Raphael are both going hiking through a park that is a fairly level ground. They both leave from the same spot in the parking lot. Mariah follows one trail, walking 4.3 kilometers per hour in a direction 40 degrees east of north. Raphael follows a different trail, walking 4.8 kilometers per hour in a direction 52 degrees east of south. How far apart are they after 2 hours? So the first thing you have to figure out is how far they've actually walked in their 2 hours. So when you look at what Mariah did, she was walking 4.3 kilometers per hour, and she did that for 2 hours. So you take those two numbers, you multiply them together. What that does is it cancels out the hours on top, the hours on the bottom, and just leaves you with kilometers. So 4.3 kilometers per hour times 2 hours means she's going to walk 8.6 kilometers in total. Same thing for Raphael. He's walking 4.8 kilometers per hour for 2 hours. So 4.8 times 2 gives you 9.6 kilometers. The other piece of this is how to draw the triangle. So they both start out at point P. So if they hadn't given you a diagram, you would need to know how to draw this. So they start at point P. It says in the question, Mariah is walking 40 degrees east of north. So when you look at your directions, it means that she's going from the north 40 degrees towards the east. So if I had my north-south line, she's going this way 40 degrees east of north. So her line is 8.6 kilometers. For Raphael, it says he's going 52 degrees east of south. So you start at your south direction and go towards the east. So if this was north and this was south, east. So 52 degrees east of south, we go over 52 degrees towards the east. That's going to be his line. And his line is 9.6 kilometers long. The question wants to know how far apart are they after 2 hours. So after 2 hours, Mariah is standing right here. And after 2 hours, Raphael is standing right here. The difference between them is going to be this side right here. We need to know this distance. There's another little trick to this. A straight line in math measures 180 degrees. What that means is if I go from right here to right here is 180 degrees. So if I start at my north line and I go all the way over to my south line, that's going to be 180 degrees. I need to know this piece inside here. And I know this chunk is 40 and this chunk is 52. And the whole thing has to equal 180. So to find this angle right here, I'm going to do 180 minus the 40 minus the 52, just like I would do for my triangle. And 180 minus 40 minus 52 is going to be 88 degrees. So inside of here is 88 degrees. Now I've got my triangle, I've got my angle, I've got my two sides. I can use this angle to find that side. The rest is just like all the questions we've been doing. So the rest of the work is down here. We're finding a side, so we write our cos law with the side off to the side. The important thing is the angle directly across from it, the 88 degrees. You work it all out, you get 12.7 kilometers. So they're 12.7 kilometers apart. Okay, similar question here. A ship travels south from port for 2 hours at 35 kilometers per hour. It then changes course and travels 20 degrees west of south for 3 hours at the same speed. How far is it from port after 5 hours? So our port is here. We're heading south. So this is our first line, heading south for 2 hours. And our speed is 35 kilometers per hour. So 35 kilometers per hour times 2 hours. Hours are going to cancel. 35 times 2 is 70 kilometers. So this side of our triangle is 70 kilometers. It then changes course and travels 20 degrees south of west for 3 hours at the same speed. So we're now going this way for 3 hours. And so we've got 35 kilometers per hour because the speed didn't change. Times 3 hours. Our hours are going to cancel. 35 times 3 is 105 kilometers. So this side length is 105 kilometers. At the end of that 5 hours, so our 2 hours of our first chunk, our 3 hours of our second, we're sitting right here. And it wants to know how far we are away from the port. So the straight line distance from the port makes the third side of our triangle. We want to know this over here. In order to find that, we have to know this angle right here, this inside angle. And again, I know that a straight line is 180 degrees. So from here all the way to here is 180. I know that this bottom piece is 20 degrees, which means the rest of it, the part I care about, is 180 minus 20, which is 160 degrees. That's important because this is now the side across, or the angle across from the side I care about, which means now I can use my cosine law to solve this. I'm solving for a side length. So I've got a squared equals b squared plus c squared minus 2bc times cos of angle A. The side I'm going to solve for, I'm just going to leave it as an A because it doesn't have a letter of its own. So my other two sides go in here. 70 squared plus 105 squared minus 2 times 70 times 105 times cos of 160, the angle across from the side I'm looking for. All of this gives me a squared is equal to 29738.5. And then my last step is to take the square root of both sides, so my squared cancels out. So a is the square root of 29738.5. So my unknown side is 172.4. I have units in my question, which were kilometers. This is now kilometers away. So my boat is 172.4 kilometers away from the port after 5 hours. The next one says, Gurjinder is a beach lifeguard. She must set up the boys for a swimming competition. Swimmers will jump off the pier, swim around one buoy, change direction and swim around a second buoy, then head back to the pier. The first buoy is 300 meters from the pier and the second is 200 meters from the pier. The angle between them is 60 degrees. How long is the swim route? So the whole route, they jump off the pier, they go to buoy number 1, they turn, swim to buoy number 2, turn again, swim back to the pier. So our entire route is going to be the 3 sides of the triangle added together, which means we need to find this side over here. There's actually nothing extra to do in this question. We're given all the information we need because we know the angle directly across from the side we're looking for. So I've got my 2 of my 3 sides. I've got my angle across from the side I'm looking for. I can use my cosine law. I'm using it to solve for a side. So a squared equals b squared plus c squared minus 2bc cos of angle A. So x squared equals 200 squared plus 300 squared minus 2 times 200 times 300 times cos of 60 degrees. When I solve this, x squared equals 70,000. Square root of both sides means x equals the square root of 70,000, or x equals 264.5 0.6, and it was originally measuring meters, so this is also meters. Not quite done. It wants the total root. So the total root equals the 200 meters plus the 300 meters plus the 264.6 meters. So our total root is 764.6 meters. Last one. On a triangular frame of bicycle, the distance from the seat S to the handlebars H is 52 centimeters. So from seat to handlebars, 52 centimeters. The handlebars to the gears is 56 centimeters, and the gears to the seat is 42 centimeters. What is the angle formed at S? So the angle we're looking for is right here. We've got three sides. We're looking for an angle. We're going to use our cosine law. The most important side is the one directly across from our angle, which makes it this 56 centimeters. We're using our cosine law to solve for an angle, so cos of our angle equals b squared plus c squared minus a squared over 2bc. So cos of angle S equals the other two sides, so 52 squared plus 42 squared minus the important one, the one across from it, the 56 squared, divided by 2 times 52 times 42. So cos of S equals 1332 divided by 4,368. We do the inverse cos to get S alone. That's going to cancel, leave us with S. So cos inverse of 1332 over 4368. And angle S equals 72 degrees. Okay, so that's it for the cosine law. You guys need to do the practice section, and then you need to do the chapter test review section. And you are going to have a chapter 7 retest on Tuesday, so make sure you get this done.